This is a fully functional weather station that I designed and built completely by myself. The weather station is made of a master and a slave, which communicate wirelessly. It measures temperature, humidity, carbon dioxide and carbon monoxide, wind speed, ultraviolet radiation. It measures particulate matter, air pressure, has GPS, a real-time clock, stores all the measured data on a microSD card, and it even runs a web server with a web interface. You might be wondering how I did this, so in this video I will walk you through the concept, the PCB design, the soldering and the testing. I won't explain every single component, but if you want that, then let me know in the comments below. The idea for the weather station was that every sensor and every component would be SMT, so the whole thing would look clean, professional and of course impressive. I started by planning which sensors and components I wanted to use. I also wanted the weather station to measure everything as precisely as possible and not just pull random values from the internet. But how did I actually design the PCBs? Now that I had a vision of the finished product, I opened KiCad and created the schematics and connected every sensor and every chip together. After running the ERC and adding a few passive components, I moved on to choosing the footprints. Because I wanted the PCBs to be compact, I chose case size 0402 for some of the parts, which turned out to be a very bad choice later on. After that came the relaxing part, routing the traces and placing all the components. I connected everything and ran the DRC a few times. Once I had ordered the components, I decided to learn from my past mistakes and check the schematics and the PCB layout something like 7 times, because I really didn't want the boards to feel like before. Then I exported the turbo files and placed the order for the PCBs, which brings me to the sponsor of this video. I would like to thank PCBWay, who sponsored the PCBs and made this project possible. The ordering process was very simple. I went to PCBWay.com, uploaded the turbo files and selected the color matte black, chose SMT stencil and checked all the manufacturing options. And I don't think that I have ever had the chance to customize a PCB that much. After checking the turbo files one more time in PCBWay's online turbo viewer, I placed the order. Less than a week later, I got a very pleasant surprise one morning. All the boards, including the stencils, were sitting outside my door. Never in my entire life have I waited less than a week for the manufacturing and delivery of the PCBs. Of course, I got really excited and immediately started unpacking everything. The boards were carefully sealed in a box, and they even included 2 PCBWay stickers. Wow, look at these PCBs. This is what I call quality in electronics. In my opinion, matte black is just the best solder mask color. The components arrived at the same time as the PCBs, so I immediately started soldering everything together. And this is when I realized that the 0402 case size was probably a very bad idea, because I could barely even see the parts, and soldering them onto the pads was nearly impossible. So I took out my stereo microscope and soldered the PCBs with its help. But this was much easier, but still not simple. It took me entire 2 days to solder everything, mostly because I had indeed made a design mistake at the buck converter, which created a short circuit, though this was an easy fix. I also went through 2 ESP32s because I somehow forgot that it runs on 3.3 volts and nothing higher. So I had to order a few more. Spare parts hadn't been one of my priorities when I placed the order. For the microcontroller, as I have already mentioned, I went with an ESP32-C6 because it has Wi-Fi and it is easy to program and easy to use. The outdoor sensor unit consists of an RS485 wind speed sensor, an SHT41 for temperature and humidity, an SPS30 particle sensor for particulate matter, which by the way cost me another $35. and an AS7331 UV sensor that measures UVA, UVB, and UVC. I also added a second screw terminal for a possible future RS-45 wind direction sensor, and a third one for a future tipping bucket train sensor. I wanted this unit to be powered by 3 lithium iron phosphate batteries because they can survive long winters without losing a lot of capacity. The batteries are meant to be charged by a solar panel, and I searched for days to find a good solar charger for 3S batteries. For now though, I haven't connected the batteries to the sensor unit yet. The indoor sensor unit, also known as the master unit, is connected to a wall socket. This unit consists of a carbon dioxide sensor, a temperature and a humidity sensor, a pressure sensor, which I had to order from AliExpress because there was no other distributor who sold it, and it still hasn't arrived. It also has a carbon monoxide sensor, GPS for position and weather forecasts and syncing the real-time clock, and it even stores data on a micro SD card. Finally, the master runs a web server with a web interface, so I can read all the measured data easily. After testing every sensor individually and programming the firmware, which I luckily have already programmed before I ordered the PCBs, I flashed the microcontrollers and tested the finished version, which worked flawlessly. So this is prototype 2 of the weather station. There are still many improvements to make. For example, I was too nervous to solder the CO2 sensor directly, so I used the breakout version instead. The GPS module is also useless indoors. The PCB still has that design mistake with the buck converter, and the weather station still doesn't have a case, which is quite impractical. And you may have also noticed that I accidentally mirrored the footprint for the carbon monoxide sensor again. Still, I'm really happy with how this turned out because it's my first SMT board and I didn't expect everything to work this smoothly, even with all the difficulties along the way. Thanks again to PCBWay for sponsoring this video and supporting the channel. Subscribe so you don't miss version 3, and if you have any features you'd like to see, then let me know in the comments below before I start designing it. Thanks for watching.